Hi guys, so I'm just setting the stuff up right now. Should be good to go in a minute. 1 second. Okay, perfect. So, yeah, we're continuing in this stream. We're going to continue what we started um, in the last stream, counting and probability on Alchemist. So, we did all the blue stuff except for this. I did that yesterday when I had some free time, the symmetry thing. So now all we have to do is correcting for overcounting with division and then like 8 red things over here. So that shouldn't be too bad. And then we'll be done. So let's start here. I want to take a picture of my 6 friends standing in a horizontal, in 2 horizontal rows of 3. Okay, so obviously I'll put some of the work on the whiteboard here because I need to show that. So basically there are 2 horizontal rows of 3, right? So one, two, three, 1, 2, 3. How many different photos can I take if the tallest person must stand in the back row, the shortest person must stand in the front row, and 2 of my friends are identical twins? And the identical twins are right in the middle. So, okay, basically we have to, um, the tallest person, there are 3 ways to put them, right? So let's say we put them here. There are 3 ways to do that. And same with the shortest person, there are 3 ways to put them over here. So that's 3 times 3. And then after that, it's kind of like just, sorry, place the people wherever they want. So that'll be 4 factorial, right? That's how many ways you can place people. Now, since they're identical twins, we need to divide by 2 because there'll be like whether, let's call the twins like T1 and T2. So this is half the cases will be like this with T1 here, half of them will be like this, T2 and T1. So basically you just divide by 2. So it's 3 times 3 times 24 over 2. So that's 9 times 12, which is 108. Okay, correct. 22 people attend a party. Each person shakes hands with at most 20 other people. What is the maximum possible number of handshakes? Assuming that any 2 people can shake hands at most once. So this is kind of similar to when you have 11 couples and then you shake hands with everyone. Yeah, 11 couples because there are 22 people. Everyone except yourself and your wife or spouse or whatever. So it's the same thing. It's 22 times 20, right? Divided by 2 because each handshake counts for 2 people, right? Like if I shake your hand, that counts for you shaking my hand and me shaking your hand. So you have to divide by 2 and this becomes 220. So that should be the answer, but it seems like, uh, okay, correct. How many ways are there to arrange the letters of this word? So banana, which has one, two, three, four, five, six, 6 letters, there are 3 A's and 2 n's. So it's 6 factorial divided by 3 factorial, 2 factorial in the denominator. So that's basically 5 factorial, 120 over 2, so 60. So that's just, mm, oh wait, never mind. They're all different. So 1, 2, 3, 4, 5, 6. So it should just be 720 then, since they're all different things. Okay, that was a trick part, I guess, because I didn't really read that. Obviously my fault, but okay, done with that then. Basic probability as counting. Okay, spinner 1 is divided into 4 equal sections, labeled 2, 3, 4, and 5. Spinner 2 is divided into 5 equal sections, if 1, 3, 5, 7, 9. What is the probability that the product is a 2-digit even number? Okay, so when you multiply them, like how many possible spins you have for 1 and 2? If you multiply that, you'll get how many possible combinations of spins can you have for spinner 1 and 2. So that's in total, how many ways are there? They're going to be 20 ways in total. Okay, so there are 20 ways in total, and they're all equally likely. Right now, you want to get an even number. since everything in spinner 2 is an odd number, obviously spinner 1 has to give you the even number. So it's either 2 times 579, which is that's three cases, or 4 times 3579. So that's 7. So it's just 7 out of 20. Because it's easy to count the cases for this. 2 can go with 5, 7, or 9. So that's 3. And 4 can go with 3, 5, 7, or 9, which is 4. So 3 plus 4 is 7. Okay, so you need at least 6 cents worth of coins to show. So there's a half chance where I did a very similar question with this. So penny, nickel, and dime. So I'll just write that penny, nickel, dime, and you need at least 6 cents. Right, so 6 cents. So if you get a dime, that's a half chance, right? Regardless of anything else. If you just roll, like if the dime is on heads, that's automatically done. So that's one half. Now we can add the probability to that you don't get a dime and you get a nickel and a penny. Okay, so you get a penny and a nickel. So this is 1/4. Then this is one half. So the probability that you get a head on the penny and nickel, so that's 1/4, times the probability that you get a tails here. So that becomes 1/4 times one half, 1/8. So 5/8. I think it is like the exact same question that I had. Yeah. Or you could have done it this way as well, but I think mine was maybe not faster, but that's just the way I think about it, I think. In a class of 20 students, all but 4 of the students put their names on a typed assignment. So you're going to have so basically there are 4 assignments that like don't have names on them, and there are 4 people. So it should just be 1 over 24. Right? That should be it. Because you have to basically um put them all correctly, right? You have to guess all 4 correctly. Okay, yeah, you can imagine it as like whatever line or something, but I don't think it really matters. I'll also take a look at the helpful tips in case there's like a square root or whatever. But nothing like that so far. Hans is staying at a hotel that has 5 doors, 1 through 5, and 10 rooms per floor, numbered 1 through 10. Hans forgets where his room is, but he knows that it is on an even numbered floor, and the room number is divisible by 4. Okay, so basically it's going to be 1 out of, and how many rooms satisfy his criteria. So you can have 20, 24, 28, or with 40, 40, 44, 48. So that's 6. So he's got 6 rooms that he thinks might be his room, and then you do 1 out of 6. Okay, wrong. On an even numbered floor. Okay, I read the wrong way. Never mind. There are 10 rooms per floor. Wait, even numbered floor. So 1 and 4 work, and the room number is 40, 44, 48. Oh no, there is no 0. So that will be 1 out of 4 then. It's either 24, 28, 44, or 48. So 1 out of 4. Done. Now this one. 8 black balls and 7 white balls. 3 of the balls are drawn at random. What is the probability that you get 2 of one color and 1 of the other color? So in total, like the number of ways to just pick 3 is going to be 15 choose 3. Right? That's like the total number of ways. Now you can do 8 choose 2 times 7 choose 1, or the other way. Right? 8 choose 1 times 7 choose 2. I think that will be all you have to do. Yeah, 8 choose 2 is 8 times 7, so that's 28. I think 8 times 7 over 2. Yeah, 28 times 7 plus 8 times 21. And then here we have 15 times 14 times 13 over 3 times 2. Okay, so this cancels out to make us 7 here. Let's try to simplify it all. This cancels obviously to make this a 5. We aren't going to do anything with the 7 yet though, because this is just 8 times 3 times 7. So we can cancel out this 7 with this 7 and this 7. Okay, now we've got 28 times 1 plus 24. So 28 plus 24 out of 65. That seems wrong actually though, because that's 52 out of 65, right? 52 out of 65, which is 4 fifths. Well, okay, wait, we could have done complementary stuff as well. We could have just seen how many ways are there to get 8 choose 3 and then 7 choose 3. So this seems realistic. 52 out of 65. Take out a 13, this becomes 4 out of 5. So it should just be that. Yeah, okay, that's stupid. I should have definitely just done complementary counting. I think that would have worked faster. Okay, so this where it gets a bit harder, but it's fine. Six-sided die, so regular die. You roll it 5 times. What's the probability that exactly three of the rolls are either a one or a two? And we don't really care about the order, right? So basically, um, exactly three. So you need in total how many ways do you have? Right? That's important to know. In total, you have 6 to the 5th. That's a total number of ways. Here we're saying exactly three of them are going to be either a one or a two. So that's two options for each, one or two, and there are three of these. Then you multiply this by 4 to the 4 squared. So this becomes 2 to the 7th over 2 to the 5th times 3 to the 5th. This cancels out to make this 2 squared. So it's just 4 over 243. And I think that seems realistic as well, right? Like it seems close enough. Let's just check. Yeah, I've done the math there, right? 4 Okay, what have we done wrong here? You're rolling a fair six-sided die 5 times. Well, we don't care about the order, so I guess you could divide this by um like 6 factorial or something, but okay, wait, let's not do that. Okay, over here we have taken into account the order, right? Like which ones, yeah. So maybe over here, since we're taking into account like which ones, I think basically, wait, what I'm trying to say is we should probably be checking the different orders as well, right? So we need to take that into account. So it'll be 5 choose 3 times 2 cubed. So you have to pick which three are going to be 1 or 2, and then make each of them 1 or 2 accordingly. And then the other two will be like that. So it's basically just this times 5 choose 3. That's the only thing that's changed. That's 5 times 4 over 2, so that's times 10. So 40 over 243, maybe. Okay, and it is correct. Yeah, and the math, like the expression that I'd worked out was correct. So, okay, so, stupid mistake there. I think it's fine though. Okay, 10 people are sitting around a round table. Three of them are chosen at random. What is the probability that the three chosen people were sitting in consecutive seats? So, the number of, not sure about that plasmics. I think you just need to be a bit more like me. Keep on practicing and solving these questions. That's how you can become a pro like me. So it'll be there are 10 possible ways to get people in consecutive seats. If you just choose the middle person, so it'll be 10 out of, and then it should be just 10 choose 3, right? 10 choose 3 for the number of ways you can pick 3 people, which is, I forgot this, 10 times 9 times 8. So this becomes 3 and 4. So 120. So it should be 10. Yeah, there are 10 possible like sets of people sitting consecutively, and then we want and in total the number of ways to just pick three people is 120, which actually seems a bit too low. Maybe I've done something wrong. 10 times 9 times 8. Yeah, that's right actually. So 10 out of 120, which is 1 out of 12. But because they've said circular, I think I have to change something. Um, because they've said it's a round table. Maybe that changes stuff. Let's try it and see. It should be right. Yeah, okay. I thought there was some trick and you had to like do something special, but okay. And they said the same thing. They just pick the middle person and then take the two neighbors. Nine people sit down at random seats around a round table. Four of them are math majors, three are physics, and two are biology majors. What's the probability that all four math majors sit in consecutive seats? Again, a similar thing. So let's try to draw it. There are nine in total, right? So let's say it's like this, and we want the math people like this. So how, oh wait, basically, how many ways are there to make that happen? Um, you can think about it by so basically we'll make a group of the math people, right? So it'll be 1, 2, 3, 4, 5. 5 factorial times 4 factorial. Wait, that's I think I've done something wrong. This is only 8 people, right? 1, 2, 3, 4, 5. Sorry, no, then it should be 6 factorial times 4 factorial. That'll give you, yeah, 9 people. So 6 factorial times 4 factorial. The total number of ways that you can. Okay, wait. So 6 factorial times 4 factorial. Um, Divided by 9 factorial, right? This will give you. So this will cancel out to make this just 3. So it's 1 out of 21. But um, I'm not sure that's quite it because we need to remember that it's a circular table, right? It's not just a line. So maybe we divide this by 9 and we divide this by 6. I think that's the step, right? I think that's what we're forgetting because you have to, fix someone to be there. Um, okay, it's either 5 factorial, 4 factorial over 8 factorial, or it's this over here. I'm pretty sure it's this one, right? I think it's that, which would be 4 factorial over 8 times 7 times 6, which will cancel out to give you 1 out of 14. So it's either 1 out of 21 or 1 out of 14. So let's try 1 out of 14 first. Yeah, okay. Okay, and they didn't even take the other people into account. So they did 9 out of 126. Okay. Okay, we finished that. So now it's probability with casework. And now we've only got 7 things left. So not too bad. Okay, let's go. Alexio has 100 cards numbered 1 through 100 inclusive and places them in a box. He then chooses a card from the box at random. What is the probability that the. So it's 2, 3, or 5. Right, so let's see. How many multiples of 2 are there? I think this is pi. So in total there are 100. We need to use the principle of inclusion, exclusion. So the number of multiples of 2, number of multiples of 3, the number of multiples of 5. So there are 33 of these, 50 of these, and 20 of these. Then you subtract off how many are multiples of 15. There are going to be 6 of those. So that means minus 6. That's with 3 and 5. With 2 and 3, that's 16. So minus 16. And then and then minus 10. Now, how many are multiples of 30? There are 3 of those. So you just add up all these things now. So first of all, 33, -6 and 3 will give you 30. -10 will give you 20. Add another 20, that becomes 40, 90, 76. So it's 70, sorry, what is it? 90 minus 16, so 74, which means 37 out of 50. 37 out of 50, I think. Unless I mess the calculations up a bit. Okay. Um, on the game board below, Kendra will start at the center of the board. For each turn, she will spin the spinner with 4 congruent sectors once, and then she will move one space in the direction indicator on the spinner. What is the probability that the sum of the numbers in the spaces on which she lands will be exactly 30 after a third complete turn? So 1, 2, 3, 1, 2, 3. So you want a sum of exactly 30 after 3 rolls. Um, in total, like how many ways are there? You have 4 options again, 4 options again, 4 options again, right? So now what are the different ways that you can get 30? So basically, okay, wait, 1 second. How many ways, how many possible like sets of 3 moves does she have? She can go in 4 directions anywhere. I checked that just now. 1, 2, 3. So after your first one, after your second one, after your third one. So in total, there are going to be 4 cubes, 64 possibilities, right? In total, there's 64. So we'll divide by that. Now you can, on the first turn, you have to go to a 10. And then after that, you have to either go to a 10 or a 15. Um, sorry. After you go to your first 10, it's going to be, let me take this picture and then draw on it. I'll try to do that. Yeah, let's take this and see. So whatever, how can you get 30? You can either get 10, 10, 10. So you go here, then you go here, then you go here. That's one case. Or you go from 10 to here and then here. So we just need to add it up. First time, wherever you go, there are 4 options, right? After that, you've got, well, okay, wait, let's break this up into different cases. So if you go right or left, that's 2. You can either go right or left. After that, you can go right and then you can go up or down. So that's times 1 times 2. Or in this case, you go left, left, and then up or down. So that's 4. Okay. The other case is if you go up here to this 10. Okay, so this is left or right? Left, right. Like basically what we did here was 10 plus 5 plus 15. Now we can do 10 plus 10 plus 10 with left and right as well. So you can go here. Um, well, actually, we can do that with anything. If we're just doing 10 plus 10 plus 10, there are 4 ways to go to like here, 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 or here. After that, you can go up or down, right? So again, you'll have like whatever 4 ways. Sorry, then you'll have 2 ways. You can either go up, down, right, or left. If you're here, you can go right or left. If you're here, you can go up or down. So it's times 2. And then wherever you go, again, you'll have 2. You can either go back up that way or this way. Here, you can go this way or this way. And so it'll be like this. This is just 4. This is 16. So it's 4 plus 16, which is 20. So it's 20 out of 64, which is 5 out of 16. Okay, a function f randomly assigns values to f of 1, 2, 3, and 4 from a set. Oh, from the set 1, 2, 3, 4 without replacement. What is the probability that f of x, sorry, f of x equals f of x for each x in the set 1, 2, 3, 4? Okay, wait. I think like f of um. So you can take the inverse of both sides once, I guess. That will give you f of x equals f of. I'm writing it at the bottom here. F of x equals f um of x. So whatever x is, you want f of x to be the same thing, right? And okay, you can take the inverse again. That will give you just x is equal to f of x, and that should just be a 1/4 chance, right? Because like let's say you want f of x to equal x, so you can have two. The probability that f of 2 is equal to 2 is just 1/4 because they choose it randomly, right? So it should just be 1/4. Now, because it's saying probability with casework, I think it's more complicated than that, but let's try it. Okay, it's wrong. So let's say plug in some values and I guess. So if we say that the first, oh, for each x in the set, that would mean that f of 2 equals f of that. So basically, so okay, f of 2 equals 3. I'm writing it at the bottom there, the same area. F of 4 equals 4, and obviously f of 1 equals 1. This is what they're saying, right? So what's the probability of that? It'll be 1/4 times 1/4 times 1/4, because the last one will automatically be decided then. Oh wait, with replacement. Yeah, okay. So it'll be 1/4 times 1/4 times 1/4 times 1/4, which is 1 over 256. I think. Okay, it's wrong. But we do know that f of a equals a, so we know that. Then f of x equals 1 for all x. Okay, first we count the total number of possible functions. There are a total of 256 possible functions. So they said f of a equals a. So, okay, similar to what we did, but obviously they did something right that we didn't. This tells us for any value of x, if we said a equals f of x, then a is a fixed point of f. We divide that into cases based on the number of fixed points. I don't know what fixed points are, so, but let's go down and see. There are four ways to choose the. So there are four ways to choose the fixed point. So okay, f of x can it be 1, 2, 3, or 4? So they picked one and they said there are four ways. Then the one possible structure is, wait 1 minute. Okay, back now. Okay, let's continue. The positions of A, B, and C. Assume that one is a fixed point, then f of x equals 1. Okay. One possible structure for the function is this. Okay, another possible structure is as follows. whatever. So they calculated the number of possible functions, which is 40. Then over here, without loss of generality, assume that 1 and 2 are the fixed points. Then f of x equals 1 or 2. So again, they found how many possible sets of two fixed points there can be. Then they looked at the cases and added them up, which gave them 48. Same thing with 3. So there are 4 ways to choose the 3 fixed points. And then, and then again they did the casework, which gave them 3. So 4 times 3, 12. And then the last one, I think that's the only one we considered. So, well, I consider it, messed that one up. I didn't look at any of the other cases, which is obviously a mistake. Um, this is definitely harder than the other ones, so it's fine, I guess. Let's try this. Bag A has 3 white marbles and 4 black marbles. Bag B has 8 yellow marbles and 4 blue marbles. Bag C has 2 yellow marbles and 5 blue marbles. If A is white, if it is white, a marble is drawn at random from bag B. Otherwise, if it is black, a marble is drawn at random from bag C. What is the probability that the second marble drawn is yellow? Okay, so this is just if it's white, so that's a 3/7 chance. Then you multiply that by the probability that it's yellow from bag. Oh, okay, yeah, bag A. If it's white, then a marble is drawn at random from bag B. And you want the probability that the second marble drawn is yellow. So that'll be 3 out of 5 plus 4 out of 7 times. Now you do it from bag C, which is a 2 out of 7 chance. So that becomes 8 out of 49. This becomes 9 out of 35. We can write this as 9 over 5 plus 8 out of 7. Wait, no, obviously that's, oh yeah, times 8 out of 7 times 1/7. So this becomes 63 plus 40, which is 103 over 35 times 7, which I don't think you can simplify that. 35 times 7 will be, what will that be? 245. Yeah, that should be it. Okay, just slightly messy calculation. Container Container 1 holds 8 red balls and 4 green balls. Containers 2 and 3 each hold 2 red balls and 4 green balls. A container is selected at random and then a ball is randomly selected from that container. What is the probability that the ball selected is green? Great. So probability of container 1 will be half. Probability of container, sorry, 1/3 because there are 3 containers. The second ball is green. So it'll be 1/3 times 1/3 because there's 1/3 chance of getting a green one. Plus 1/3 for, well, it'll be 2/3 because the containers 2 and 3 are identical. So it'll just be 2/3 times the probability of getting a green ball there will be 2/3. So 4/9 plus 1/9, which is 5/9. Okay, great. 3 cards are dealt at random from a standard deck of 52. What is the probability that the first card is a 4, the second card is a spade, and the third card is a 2? Okay, so I think the point here is that you can have the 4 being a spade, sorry, not a spade, a club. The 4 can be a club. The second card can be a 2. So those are the different cases, right? We need to worry about that sort of stuff. So let's copy it. Let me just copy the question and see. First card is a 4, the second card is a club, and the third card is a 2. Okay, let's see. So I'll drag this down a bit and get some room. All right. So let's say let's take the case that four is a club. Four is a club. Uh, okay. So four is a club. Four is not a club. All cases are covered. Then over here we need the club to be a two. Club is a two. Club is not a two. And then same here. Club is two. Club is not a two. Okay, so we need the first one to be four is a club, right? So what's the chance that that happens? What's the probability of that? Um, that's just 1 in 52, right? You have to get the four of clubs. Actually, I don't even know if clubs is the right thing, but I might just be wrong. But so 1 in 52 times what is the probability that the club is a two as well? There are 51 cards because you've taken the four of clubs. There's obviously only one two of clubs. So that will be 1 out of 51. Oh, and then we also have to remember that the third card has to be a two. So now there are 50 cards left. How many twos are left? So obviously this one wasn't a two. The club is a two. So there are only going to be three left. So it's 3 out of 50. Plus now over here it's going to be it's not a two or a four. So it's 10 out of 51 rather than just one. The only restrictions are it can't be the four of clubs obviously or the two of clubs. So it'll be well no then it'll be 11 I think because there are 13 of each, right? So okay, 11 out of 51 times club is not a two for and the first one is not a two either, so that means there are still four left out of 50, which means 2 out of 25. Okay, well let's leave it as 4 out of 50 actually because we've got the same stuff here. So this is our first case, right? 4 is a club. Very similarly, we can do 4 is not a club. If 4 is not a club, it'll be um there are three of them, right? It's either a spades, heart, or diamond. So that's 3 out of 52, which can't be simplified unfortunately. And then over here, what do we add to it? Well, we'll add club is a 2. Again, um well, 4 is not a club, which means there are 13 clubs. So it's wait. The second card is a club. Okay, yeah. So it'll be out of 51. It'll just be 1 out of 51 again. Times. Now we've got, well, same thing, right? It'll be 3 out of 50 because there are 3 left. Now here, next case, club is not a 2. So there are going to be 51 cards here. 4 is not a club. So the club can be anything. It can be the 4 of clubs if it wants to. Just can't be the 2. So that's 12 out of 51 times. And I know that can be simplified, but I'm not doing it right now to save uh, time in calculating. Club is not two. And then if the club is not two, we need a two. So there'll be four of them. So it should just be 4 out of 50, right? I think I've messed some of this stuff up, but whatever. Now we have the denominator of basically the denominator will be 52 times 51 times 50, right? Let's do this one first. It'll be 1 times 1 times 3. So that's 3 plus 44 plus 3 times 3 plus 48. So that's 47 plus 3 times 51. 47 plus 3 times 51. 48. Yeah, 1 second. 48, 51 times 3. That's 153, right? 153. So that cancels out nicely, actually, like, very nicely. 47 plus 153 is 200. So this becomes 4 and the 50 will just go away. Now that this is 4, this becomes 13. So it'll be 1 over 13 times 51, I think. Um, Now we just need to multiply it. So that will be 510. And then again 153. Add these up. 366. So 1 out of 663. Okay, we got it. That was actually extremely messy. So very glad we got this. And the calculations weren't too bad either because we didn't have to. Okay, let's see this question here. The probability that the first card is of 4 is 1 in 13. So what's the probability that the first card? Okay, we could have done it in a different order. That's what the second solution is saying. Okay, so they did this. Finally, the probability that the third card is a club is 1/4. Okay, it's a much smarter way to do it. And okay, so it's a smarter way. You change the order and then the calculations become easier and like you don't have to do casework then. But okay, it's good question. It was just like a bit messy to do all the calculations. I'm glad I got that right though. Okay, there are 30 students in Mrs. Taylor's kindergarten class. There are twice as many students with blonde hair as with blue eyes. Six students with blonde hair and blue eyes. So basically, it'll be it's we can make a table like this, right? So either they have blonde hair. So this is hair. The hair can be blonde or not blonde, and then the eyes can also be blue or not blue. So it's like this, right? Now we know that six students with blonde hair and blue eyes. So six students over here, blonde hair, blue eyes. Um, And then besides this, there are three students with neither blonde hair nor blue eyes. So that means there'll be three here in this section. There are twice as many students with blonde hair and blue. There are twice as many students with blonde hair as with blue eyes. So let's call this X and call this Y. Right? This is the people with blonde hair. So 6 plus X is equal to 2 times blue eyes. So 6 plus Y. That's one equation. And the other equation we have is since there are 30 people in total, right? Yeah. So x plus y is equal to 21 because there are 9 people here and we want to add up these two as well. So I think we can just put that in. Now x is then equal to 21 minus y, right? This is x. So it becomes 27 minus y equals 12 plus 2y. Now we just simplify this a bit. So y is equal to 5. Y equals 5. We can solve that. Okay, so y equals 5, x is then equal to 16, obviously. How many students have blue eyes? That's what they're asking us. So it'll be 11, and yeah, that's our final answer. And they did almost the exact same thing. Um, well, no, not really. They did a Venn diagram. I did the table. I think it's fine though. Jerry goes to sleep at 11 p.m. each night, but he doesn't sleep very well. So he wakens at a random time between 1 a.m. and 3:59 a.m., with each minute equally likely. He then reads the hour and minute hand shown on his clock as a three-digit number. So 2:56 a.m. would be 2:56. What is the probability that the number will be divisible by 7? So how many numbers are there in total? And how many of them will be divisible by 7? We go from 100 to 159, which is 60. Then 200 to 259, 60, 60, 60. Right? So that'll be out of 240. There are 240 possible times. When you go from 100 to 159, how many are multiples of 7? So the first one is 105. The next one will be 140 and then 154. Right? So that's 15. When you divide it by 7, it's 15 and 40. Sorry, 22. Right? 15 and 22. So that's 8. There are 8 in that range. Now we can go from 200. I'll do it at the bottom here. 200 to 259. So again, the first one will be 203 now. And the last one will be um we can add like 56. So well, 259 itself will be divisible. So we can divide it by 7. That will give you 29. And then this one is um well, what's the difference? Just divide that by 8. Can't we do that? 7. Yeah, divide the difference, 56. So that should be 9 then. I think that's 9. Similarly, we can go from 300, yeah, 300 to 359. Wait, I'm missing something, right? 1 to 2, 2 to 3, 3 to 4. Sorry, they're not 240 then. They're only 180. Only 180 ways. I messed that up. It's 1 to 4. That's only 3 hours. So that calculation was wrong. This is the last one. So 301 is divisible. We know that. 301. And then what's the next one? It'll be again 56 more than that. 357. So this is again 9. So it's 18 plus 8, which is 26 out of 180. Take out a 2 on both. This becomes 13 out of 90. 13 out of 90. Okay, perfect. So it's the same thing as what we did. 7, 8, 9. 7, sorry, 8, 9, 9. Those are the possible numbers in each set. And then there are 180 minutes. So 13 out of 90. Perfect. Four people sit around a circular table and each person will roll a standard six-sided die. What is the probability that no two people sitting next to each other will roll the same number after they each roll the die once? Okay, there are a few different cases here, right? We can draw the circle here. Let's just put our people like this actually. Right, let's put them like this. How many possible, well, okay, we can do it just with probability, right? This person can roll whatever they want. The probability that this person doesn't get the same thing is 5/6. The probability that this person gets the same, so let's call this person A, this one B, C, and D. There are two cases that we want to consider. If B equals D, so let me write them down a bit. Let me write them down here. B equals D and B does not equal D, because these will give two different results, right? This person can be whatever they want. Now this person, they can be anything except A. So that's 1 minus 1/6. So 5/6. The probability that D is the same as B is 1/6. Now this person can be anything except what D and B are. But since D and B are the same thing, that's just 5/6 again. So this is 25 out of 216. Right? What about B is not equal to D? Then D is it's got a 2/3 chance, right? 2/3. It can't be whatever A was or B. So that's 1 minus 2 over 6, which becomes 2 over 3. And then this one can also be, this will only be 2/3 again, because you can't be D or B. So it's 1 minus 1/3, 1 minus 2/6. And multiplying this stuff together, we get 20 out of 216, which means together we get 45 choices out of 216. 45 out of 216. So when we simplify that, take out a 3, this becomes 72, and this becomes 15. Again, you can take out a 3. We could have just taken out a 9 actually. This will give you 5 out of 24. So 5 out of 24. Okay, wait, it's wrong. After they each roll the die once. I think I like took everything into consideration when I drew the thing here, right? Because there shouldn't be any extra rotations or whatever. Um, yeah, like whatever A is. Okay, what could I have done wrong here? Maybe you have to, like, how could it be off? I don't think it changes, right? Like over here, we just fixed A to sit on the right. Basically, we fixed them in that position. Then there are two cases. There's one case where you have 1/6 times 5/6 times 5/6, which is 25 out of 216. And okay, wait, doesn't seem to be wrong here, but obviously it is wrong. 5 out of 24. Let's go, wait, let's go about it in a different way, actually. Right? Let's go about it in a slightly different way. But I think it will just end up being the same exact thing. Let me think about it for a second. Yeah, the other thing I was thinking was we can do A, B, and then do the casework on C instead. Right? Like just say either C is equal to B or C is equal to, or C is not equal to, sorry, either C is equal to A or C is not equal to A, but that's the exact same thing. So maybe we have to roll the dice. Maybe we have to, sorry, maybe we have to multiply it by 4, but then it becomes a 5/6 chance, which just seems like, way too much. The, yeah, that means that, hmm. Okay, but we did this can be anything. If this is the same thing, then this can be 5 out, then there's a 5/6 chance for this, 5/6, and so basically we have 1 times 1/6 times 5/6 times 5/6. Then we have 1 times 2/3 times 5/6 times. Oh, that's a problem. I'm stupid. I multiplied them wrong. I think that's a problem because this isn't a 6 or a 6, right? It's 2/3 and 2/3. So this part is correct. This is 25 out of 216, but this will be 20. No, not 20. This will be 80 out of 216, I think. 80, right? Yeah. So, mm, because this, if you want to make them all with the same denominator of 6, you have to multiply this by 2, which will make it 4 out of 6 and 6. And that multiplies to 80. So it's 105 out of 216, which is like right around half, which does make more sense as well. We can now only take out a 6. No, sorry, we can only take out a 3, which will give you on top, you'll get 35 when you take out the 3, and in the denominator, you'll get 72. So it's like just below half, 35 out of 72. Perfect. Got it. We're done with that section as well now. Now it's complementary probability. Um, let's see. Binomial probability. This, let's just look here. Let me just try it because I actually haven't done binomial probability. Like I've never actually read about it. I just guessed that it's probably like what it sounds like. So 1 second. What is the probability that I get exactly two heads? So you can pick like which two um tosses you want to have heads. And that'll be, yeah, so you can pick which two are going to be heads. So that's 5 choose 2. 5 choose 2 times 2/3 squared, because you need these to be heads, times, and then the other 3 will all be tails, right? So that'll be 1/3 squared. And then you divide this by 2 to the, wait, no, I'm doing it wrong. What if we get the first one wrong and then just see? Actually, better will be if I just pause the stream and like read the chapter in the book and just take a look. So I think I'll do that. Um, I'll just quickly read the section there, just do see a few practice questions because I'm not too sure. I haven't been able to I haven't been able to find it yet. So let me instead just uh like check their website. It's probably over there. Binomial probability, right? Because it should definitely be somewhere here if they had. Not here, not obviously not an introduction to probability. Uh, Not here either. Okay, that's like other stuff. The hockey stick identity. Yeah, no, not there. Binomial theorem. Not sure. Maybe we should just get one of the questions wrong and see. What is the probability that I get exactly two heads? Well, actually, yeah. Basically, you have to get um. Maybe it is just this, like whatever I just wrote here. Uh, where did it go? Five times. Sorry, five choose two. So this is the how you can pick the two that are going to be tails or like heads. And then you multiply it by 1/3 cubed. Maybe it's just like that. Five times five choose two is 10 times 4/9 times 1/27. So this becomes 40/243. I think it's wrong though. 40/243. Okay, it's correct. So okay, this is the part that they're talking about. Alternatively, we can view flipping this coin five times as being equivalent to the expansion of this when h equals 2/3 and t equals 1/3. Okay, so same thing. Um, the probability of getting rain on any given day in June in in capital city is 1/10. What is the probability that it rains on at most 2 days in June? Wait, so how many days are there in June? Um, January, February, March, April, May, June. June has 30 days. Then July is 31, September has 30, October has 31. So June has 30 days. So what's the probability that it rains on at most 2 days? So either 0, 1, or 2. I think it's easiest to just do it like that. What is the probability that it rains on no days? That's the probability. That's like 1 minus 9/10 to the 30th. Right? This is that it rains on 0 days. If it rains on 1 day, it'll be 30 to pick which day. That will be 1/10. And the rest of them, it'll be 9/10 to the 29th. And if it rains on 2 days, it'll be 30 choose 2 times 1/10 squared times 9/10 to the 28th. These are like very ugly answers, right? So let me take out my calculator and see. And we want it as a decimal to the nearest thousand. So this is what we have right now. 1 second. 1 minus 0.9 to the 30th power plus that's basically just 3 times 0.9 to the 29th power. Uh, yeah, and then plus what is 30 choose 2? We should just quickly calculate that, I guess. 30 times 29 over 2, and then basically over 200. So this cancels out with this. Okay, so it's 3 times 29, which is 87. So 87/20 times 9. So okay, wait, times 0.9 to the 28th power. Huh? Oh, it's not 1 minus that, right? It's not 1 minus that. It'll just be 0.9. Yeah, wait, why would it be 1 minus that? That's a probability that it rains every day. And so it would be a very small probability. So this should go away. It should just be 9 over 10. And that makes sense as well because that's what you'd have in the normal binomial theorem as well, right? 9 over 10 to the 30th. Great. So I'll just edit that here then. 1 second. 0.41. Actually 0.411. Okay, good. Uh, yeah, and they did the same thing as we did, so not bad. What is a six-sided dice are rolled? What is the probability that exactly two of the dice show a one, and exactly two of the dice show a two? So you have to do six choose two to pick the one, right? So let's see, six choose two to pick the one. Then you have 1/6 squared. Then you have four choose two ways to pick the other two, and then you have again 1/6 squared because they have to be two. And then the other ones will just be 2/3 because it can't be a one or a two, right? They can't be one or two. And then that will also be squared. So okay, and what is it? Common fraction this time. So we don't need to do that. 6 times 5 over 2, that will be 15. So it's 15 over 36. 4 um 4 choose 2 is 6, so 6 times 1 over 6 squared will just become 1/6 times 4 over 9. So right away we can probably cancel out a 3 here to make that 5. Cancel out a 4 and make it a 2. And this will go away. Then with the 2 we can make this 18. So it's 5 over 162. Okay, great. Okay, this isn't as bad as I thought. Then I thought it'll be hard. 10 six-sided dice are rolled. What is the probability that exactly 3 of the dice? So it's 10 choose 3 times 10 choose 3 times um 1 over 10 cubed times 9 over 10 to the 7th. Okay, again it's a decimal. So what is 10 choose 3? I think that I have to calculate myself, right? 10 times 9 times 8 over, well, basically over 6, but I'll write it out like this. That's 120, right? This is 4. 1272. Yeah, 4. So 120 times 0.001 times 0.9 to the 7th. 0.057. So this got a very low probability. And that makes sense as well, right? It shouldn't be a high chance at all. Okay, it's wrong. Uh, 10 six-sided dice are rolled. So yeah, it won't be 1/10 then. It'll be 1/6 and 5/6. So 10 choose 3. So again, it's 120, right? But now it'll be 1 second. It'll be 120 times what will be our first one? Like what will our first thing is 1/6. So 1/6 to the third power. Then you multiply it by 5/6 to the seventh power, which is 0.155, which is a decent chance, right? It's about twice or thrice so much. Okay, great. One more. Four packages are delivered to four houses, one to each house. What is the probability that exactly two of them are delivered to the correct houses? So the two houses that are correct, you just have to pick those, right? You just literally just that. Or wait, I think it'll be a bit harder to do this using binomial probability. The chance that, okay, it'll be for choose two to pick which two houses are going to be like correct, right? Like which are going to get delivered correctly. Then you multiply it by 1/4 for the first one. There's a 1/4 chance that you get the first one right, and there's a 1/3 chance that you then get the second one right. Then you multiply that by, okay, now there are two more houses. You either get it right or wrong. So you just have to pick one of them and pick it to go in the wrong direction. So it'll be 1 over 2 to go to the wrong house. So this becomes 1 over 24, 6 over 24, which is 1/4, which is probably wrong. Okay, it's correct. 6. Okay, great. Great. Last one now. Pat wants to select 8 pieces of fruit to bring in the car for the people he's driving to Montana with. He randomly chooses each piece of fruit to be an orange, an apple, or a banana. What is the probability that exactly 3 of the pieces of fruit are oranges, or exactly 8 of the pieces of fruit are apples? Now, you can't have 3 pieces of the fruit be oranges and 6 be apples, so there's no need to do that. We can just calculate them separately because there's no overlap where both happen. Um, okay, so 8 choose 3, right? 8 choose 3. How many different fruits are there? There are 3, right? Orange, apple, or banana. So there are 3 options. So it'll be 1/3 cubed times 2/3 to the fifth. Plus, this will be 8 choose 6, which is obviously 8 choose 2, times 1/3 to the sixth times 2/3 squared. Okay, so this seems right. Now, what do they want? They want it as a fraction, I guess. Yeah, a fraction. So let's see, what is 8 choose 3? That's 8. That says 56. This becomes over 27 times. Well, actually, let's ignore the denominators for now. Okay, let's do this instead. Times 2 to the fifth. Because the denominator for the whole thing will just be 3 to the eighth. Right? We already know that. Now, what is 8 choose 6? That's 8 choose 2 basically. So it's 8 times 7 over 2, which is 4 times 7, which is 28. This is 8 times 7, that's 8 times 7 over 2. So that makes sense. And this will just be times 2 squared. So 56 times 2. Wait, let's add it back actually, all of it. This becomes plus 56 times 2. Let me scroll down and write it. Basically just that, right? 56 times 2 to the fifth plus 2, which means it's well, 112 times 2 to the fourth plus 1 over 3 to the eighth. We can't cancel out anything right now, it seems. 16, 17. Yeah, like literally nothing can be cancelled out. I think I'll use a calculator for this then, right? Like, wait, I think I've messed up some of the stuff though. There are 8 pieces of fruit. Whatever, let's see. So it's 17 times 112. Neither of those divided, right? 1904. 3 to the eighth is 6561. So there's nothing we can cancel out. But actually, the numbers aren't that bad either. 1904 over 6561. 1904 over 6561. Okay, it's correct. I didn't want to do the calculations in that because it's a bit late actually. I don't want to waste too much time on this stuff. Complementary probability. Okay, now there are only five things left. So we haven't done a lot today, but these ones were a bit longer at least. Let's do Pascal's triangle. Hopefully there'll be some easy ones. So the fourth element will be 15 choose. Wait, sorry. Yeah, row 1 is 1 choose 0, 1 choose 1, row 2, row 3. So row 15 will be 15 choose 3. Since I've done that, I think I'll use a calculator again because it's a what's it called? This is a graphing calculator and I need to use it for some exams, so I should get some practice with it anyway. It's 15 choose 3, which is 455. What is the 39th number in the row of Pascal's triangle that has 41 numbers? So each row just has one more, one more, one more, right? It's like it's 1, 1, 1, 1, 2, 1. So that means it'll be, so this is 1 factorial, right? If it's got 41, it'll just be 40. So it'll be 40 choose what? The 39th number. So it'll be 38. 40 choose 38, which is just 40 choose 2. 40 times 39 over 40 times 39 over 2, which is 20 times 39. That's it. So it'll just be 780. I think 780. There are four even integers in the top 5 rows of Pascal's triangle. How many even integers are in the top 10 rows of the triangle? Wait, this seems much harder, right? So it's let's see like what they want us to do. 1 2 1 1 3 3 1 1 4 6 4 1. Then it's 1 5 10 10 5 1. Like, I'm not going to manually do it, but okay, maybe we can go around doing it like this. On here, you're adding 2. Wait, wait. Um, the middle number will always be even, I think. Like 1 2 6. Then it'll be 20 after that. No, there has to be some fast way, right? Like basically, okay, over here there are 2. Then over here there are 3. Over here there are 2 again. Here they're going to be a lot more. 15 20 15 6 1. Over here there are 3 again. In the next one we'll have 7 21. This will be 35. Wait, yeah, 35 35. Maybe we can just manually compute it then because I don't think you can really do it otherwise. And remember, it's the 10th row, right? Yeah, so it's just 10 rows and we're already like almost done. 21, this will be 21, this will be 7, this will be 1, then 1 8 28, um whatever this is again even. We don't even need the numbers actually, we can just say even or odd, right? Even, this will be even as well, this will be even, this will be even, this will be even, this will be 1. um then this will be odd, this will be odd. I know it looks like a 0 but it's not supposed to be. This will be even, this will be even, this will be even, sorry, this will be even, this will be even, this will be even, this will be odd, this will be 1. So I guess that's it then, right? That's 10 rows. There was definitely a faster way to do this, but I guess it's fine. 1 2 3 4 5. The first 5 rows they said had only 3. Had sorry, had only 4. So yeah, we already know that there are 4 over here. 1 2 3 4. Now over here there are 2. So that's 2. Over here there are 1, 2, 3. There are 3. Over here there are 0. Right, over here there are 1, 2, 3, 4, 7. And then over here, how many are there? There 1, 2, 3, 4, 5, 6. 6. So we just add these up. This will give us 18. 18 plus 4, 22. Okay, and they did it as well. Like they just listed them out. So I think that was the proper way to do it then. In the row of Pascal's triangle that starts 1 and 11, what is the ninth number? That's just 11 choose 8, right? 11 choose 8, or well, basically 11 choose 3. So what is 11 choose 3? 11 times 10 times 9 over 3 times 2, 33 times 5, which is 165, I think. Okay, next. How many ways are there to answer a 10 question true or false test where at least 3 of the questions have been answered with a false? With a false. I don't get it. How many ways are there to answer a 10 question true or false test where at least 3 of the questions have been answered with a false? So you can just say there's 7 left. They can be anything. So okay, you can pick the ones that are false just with 10 choose 3. Right? You can just say that'll be, well, okay, 10 choose 3. I need to use my calculator, so I'm just multiplying that in. 10 choose 3. Then the other ones are 7s. That'll be times 2 to the 7th because each of those can be true or false, etc. And so in total, there should be 15360. Right? 10 choose 3 to pick the ones that have to be false. And then all the other ones can be something else. But this does repeat a lot as well, right? Won't this repeat like, okay, it's wrong. Where at least 3 of the questions have been answered with a false. So yeah, I mean, you can set them to be. So what could be wrong in the logic right now? If you have any ideas, you can put them in the live chat. Okay, just if you think you know what I've done wrong, or if you know the answer, just write it in there. How many ways are there to answer 10 question? Two or false test. So 3 have to be false. So we can pick which 3 are going to be false. And then what? Or maybe that's just it though. Like maybe did I copy it correctly? That's the first thing. 15360. Right. Okay, what is just like 10? What's 10 to see? 10 times 9 times 8 over 6. So 120. Yeah, so the answer that I'm getting here from doing 10 choose 3 times 2 to the 7th is correct. But at the same time, like, there's so many different combinations, right? The 10 choose 3 and then that. Um, there are a lot of different things you could get. Like, okay, let me go back here. If I did, if I said this is false, this is false, this is false, and then the rest were like this, like true, 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 false, false. What if I instead said that the 3 that I'm setting to be false are, I could have already started them off like this, right? And then after that, true, 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 after that, true, true, false, false, true, true, true. Like these are all the same things. So this is the same thing, right? So how many, maybe we, this is the same thing, and how many possible, wait, maybe you need to change the way we're going about this. Let's do it with like five. Uh, let's do it with four with at least two falses. Okay, there are two false, at least two falses, and there are four questions in total. Right, one, two, three, four. How many ways would this be? Would it be like, so it could be four choose two, which is six times two, which is 24. Or on the other hand, we can pick, so based on what we did there, which is four choose two times two squared, this is 24. But that's not, that's obviously wrong, because you can have like false, false, true, true. Um, first of all, you can have all falses, right? That, like four falses, that's one. If you have three falses, that's going to be two. Sorry, that will mean, that will give you four. And if you have just two falses, then it, okay, then it'll be four choose two. Okay, I see it now. So it's four choose zero plus four choose one plus four choose two. Right? That makes sense. Um, Now the other way we could, well, no, not really. It's four choose four. We're getting messed up here. Times four choose three, plus four choose three plus four choose two. Right now, if you had five on the other hand, that would probably make it clearer. It would be five choose zero plus five choose one plus five choose two plus five choose five plus five choose four plus five choose three plus five choose two. Um, so it's basically the opposite. It's starting from the top to the bottom, which means that this will also be the same as just 2 to the fourth, right? Because 4 choose 0 plus 4 choose 1 plus 4 choose 2. When you add them all up, you'll end up getting 2 to the fourth. So it's this 2 to the fourth minus 4 choose 0 plus 4 choose 1. Right? That's another way to say it. And so now if you did this with three questions, at least three questions, and 10 in total, it would be 2 to the 10th minus 10 choose 0 plus 10 choose 1 plus 10 choose 2. And I think that's it. Okay, I think that's it. Because that would give you the sum of everything after that. 10 choose 3 plus 10 choose 4 plus 10 choose 5. And this makes sense as well. Like this, it makes sense that this would be the way to go about doing it. So now I'm not going to actually do it. Well, actually, yeah, 2 to the 10th is 1024. Then you subtract off 1 minus 100 minus 10. So minus 111, which is 913, which makes a lot more sense as well. Like there's no way it's going to be that much. Okay, so stupid. Actually, so stupid. I put 100 instead of the, for 10 choose 2, I put in, yeah, I seriously messed that up. But the point is that it was all correct. Now let's just do this then. Okay, wait, it's either 9 or the other one. So it'll be 24, right? Okay, that's just a property that I saw somewhere. 17 choose 10, 17 choose 11, and 19 choose 12. 50388. So, well, how could you go about doing it? 18 choose 12. I think you have to obviously do something with the number, right? You have to figure out how to do that. So, this would be the 18th row, right? This is the 18th row. We'll also 18th row meaning 19th row because it starts at 0. So this would be row 18 and there'll be 19 things in it, right? Row 19. Yeah, whatever, row 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now let's copy paste it like just this part above, and then let's copy paste this thing below as well. Oops, 1 second. Obviously, like we don't need to draw these many, but I just want to do it to make sure I do everything right. I don't want to make a stupid mess up like the last time because that really I had no business messing that up. Okay, now 17 choose 10. So that will be over here. That will be in the 11th spot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 17 choose 10. This will be 17 choose 11. This will be 18 choose 11. Like, well, uh, yeah, 18 choose 12. So won't 18 choose 12 just be, this one would be 11, this would be 12. So this is 18 choose 12. Okay, and now they want us to find, oh, and we know 19 choose 12 as well. 19 choose 12 will just be one to the left of this, isn't it? So it would be 19 choose 12 should be right there. We can count it 19, 18, 17, 16, 15, 14, 13, 12. Wait, wait. 18 choose 12 won't be there then, I guess. Oh, I did this wrong. Um, There's supposed to be one more here, right? Like 18, how many did I put? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There should be one more in each of these. I think that's what I'm missing. Now it makes sense, right? Because this would be 18 choose 18, choose 17, 16, 15, 14, 13, 12. And so, yeah, now we know this would be 19 choose 19, 18, 17, 16, 15, 14, 13, 12. So this would be 19 choose 12. So we know that 17 choose 10 plus 17 choose 11 would be this, right? That's just from Pascal's triangle. So it's 19 choose 12 minus 17 choose 11 minus the other one. I know the values, obviously, they told us that. So it'll be 50388 minus 19448 minus 12376, which is 18564. Okay, done. The answer is correct then. So, okay, that makes sense. What, okay, now this is a bit longer. I saw these questions before as well. Like, I have seen them, but they just take kind of long, I think. So, I don't really want to do that. Uh, let's skip that or like leave it for now. There's still four more things left though, right? And I don't want to. Okay, let's do expected value. I think we can do at least two questions here, right? What is the probability that you have none? Right? What is the probability that you have? Okay, this will take time. And Jerry, I have school starting in like 1 or 2 days, day after tomorrow. So I have to get ready for that as well. There are four things after. I think I'll do these later then. Maybe whenever the next stream is. But anyway, we have finished number. Wait, no. Let's finish this off then because some mistake happened. Maybe I think I was doing some pre-algebra thing and I messed it up. So I got that wrong. But let's do this then. Okay. How many different prime factors does 20 factorial have? How many primes are there under 20? 2, 3, 5, 7, 11, 13, 17, 19. That's 8. So it's 8. The volume of the box is this. All of them are integers. What is the largest possible value of b? So basically, 2 and 3, take those out. That gives you 6. So it should be 40. Okay, wait. B is in the middle. Okay, so another stupid mistake by me. But basically, we want to make C 2, right? And that will leave. What is 240? 240 is 24 times 10. So it's 2 times 5 times 2 cubed times 3. 2 to the fourth times 3 times 5. Right? That's 1648 times 5. Yeah. We want the lowest one to be. We'll have the lowest number be 2, which will leave us with 2 cubed times 3 times 5. Using this now, which multiplies out to be whatever 120, I think. We want to see what number works. Uh, and the obviously the you want to have them as close to each other as possible. So 8 times 3, 24, and 5, not, that's too much. 20 and 6 is too much. Wait, what? Yeah, 20 and 6 is too much. So the numbers that are closest will just be 15 and 8, I think. Or 10 and 12. So it'll be 10. 10 will be the maximum value of B to have it be close to the other thing. Okay, now we have finished number theory completely, I think. I do like though that Alcumus will put random things in sometimes to make sure that you still remember everything. That's obviously very useful. But anyway, now we're done with number theory. If we look at counting and probability, it's basically done. Like just four things left, which is a lot, but we'll be able to do those soon enough. Pre-algebra, like I don't really want to do it. Um, but we might later. Like maybe in one day we'll try to do the whole thing because they're easier questions. Similar stuff with algebra, like these are easier level things, right? Geometry is harder, but here I actually have done quite a lot already. Lot of blue, a lot of green. There's progress in most things. And then intermediate algebra, um, not too bad either. Pre-calculus is bad, right? I've only done the first few things seriously. So anyway, right now we finished number theory. That's 1 out of like 7. Let's move on. We'll finish counting and probability soon. That'll be 2 out of 7. Pre-algebra and algebra, I'm not really going to count them. So I think right now we're like halfway done with Alcumus. Right, halfway done with that. I should probably, yeah, I'll keep this here right now so that I have it on video and I can see later. 503 right in one try, 127 right in two tries, 88 wrong, 19 give ups. Uh, Whatever. Basically, yeah. Yeah, I normally don't look at my stats, so I'm just looking right now. Let's look at the Hall of Fame as well. None of this stuff matters actually. Let it be. Anyway, basically, I'll need to keep on working on this. Uh, and actually, yeah, after I'm done with that, maybe I can move on to just playing for the win sometimes, or math constant, or I think that's it. Anyway, there's a lot of stuff here. So the stream has been going on for pretty long already. I don't really have anything else to say or do here. So that's it. Uh, Thanks for watching. I'll see you hopefully soon. Not sure exactly when, but that's it for today. So bye.